Hello, our most valued student. My name is Confident and welcome to our lesson. And I just want to talk to you about the electrolytic cell and just lay some foundation so that whenever I come across some past papers, which I will be revising with you, you'll be able to understand what we mean by an electrolytic cell. So let's start by discussing the basics that you find in an electrolytic cell. So first of all, let me sketch the electrolytic cell to say if you have here, we have your battery or your cell. Alright, so there is our cell, and then what we have is inside we have so what we have, this is an electrolytic cell. So I'm just going to do some labeling here. We say this is your battery, or it's a cell since it's one. And don't forget, when we're talking about a cell, we have the positive and then we have the what? We have the negative. So I'm saying this is the negative and this is the positive. All right, and then what we have the electrodes. Now these electrodes, we can name them like this to say we have this one and that one being the electrodes. So these are the electrodes. Now some information that I just want to bring in here is that what is it that you know about the electrons? Number one is that they are inert, meaning they are unreactive. So you don't want them to react with whatever is inside here. They are inert, unreactive, or you can say they are stable. They do not take part in the reaction that is taking place. And then an example of these can be graphite. So this is the example that is common when it comes to these electrodes. Number one, they are made up of graphite and they are inert. And then what we have is the electrolyte. So if I can have my electrolyte like this to say, let's say I have my electrolyte like this. So this is my electrolyte. Inside here is the, now also they will want you to define what an electrolyte is. So what is an electrolyte? We are saying an electrolyte is a substance. This is a substance that conducts what? That conducts electricity. Electricity. And what does it do? It converts. So when you're talking about the electrolyte, it converts chemical energy, electrical energy, sorry, because you pass in electricity from the cell. So it's electrical energy into what? Into chemical energy. All right, so that's the second thing about the electrolyte. Now when you talk about the electrolyte, you bring in the actual name of this particular cell. What we call it an electrolytic cell, as I said. And what is an electrolytic cell? We are saying it is a cell that converts. See, you need to know such words. I'm describing them because they want you to know them. So it is a cell that converts electrical energy into what? Energy into chemical energy. All right, so that you are expected to kind of know, you are expected to kind of understand. And then what we have, since we are saying, okay, this is an electrolytic cell, and we are saying these are the electrodes, and then now one thing about the electrolytic cell, the electrolyte, let's talk about the electrolyte. One thing further that we can bring in here is that the electrolyte must be molten or aqueous. Don't know whether that's spelling aqueous, but it's aqueous for AQ, meaning it is dissolved in water. So you'll discover that it might be molten, or here means dissolved in water. So when you're dissolving it in water, what you're trying to do, we are saying for it to be an electrolyte, it must have free ions, right? And by ions, we've got two types of ions. We have got the positive ions, right? And we've got the what? The negative ions. So we have the positive ions and the negative ions. What do we call the positive ions? We call the positive ions cation ions. I always say to students, remember when you're talking about cation ions, in that cation ions you see the positive cation ions. So there is that positive to remind you that it is the positive ions. And then what we call the negative ions is the anions. Anions, more like anions. So these are the negative. Now, with that being said, we're saying the electrolyte then will have positive ions and negative ions inside the solution. And then let's come to the description of this cell here. So what happens to this cell? We are saying we have got, as you see, the positive and the negative. So automatically the positive terminal, the electrode also becomes positive. So let me make that thicker. So the electrode becomes positive. For the negative terminal, the electrode also becomes negative. Are you with me? So now what actually happens whenever things are happening now, whenever the cell is in operation, when the switch is turned on? So what you have, as I said, you will have your positive ions and your negative ions. So let's call the positive ions X minus. They will be in this solution. And then let's call the positive ions, okay, let me just say they are randomly in this solution. And let's call the positive ions, let's call them Y plus and Y plus. So the question is, what happens whenever these ions are inside like this? So what happens is, remember, the opposite charges attract. So you will find the negative ions, we call them the anions, they will be attracted. This is attract. See? And then what happens also? The positive, which is the cations, they will be attracted there. Now, what do we call this electrode? We call this electrode the cathode. You see? Why? Because it is attracting the cations. You see? It attracts the cations. Okay. And then what do we call this electrode? We call it the anode. Why? Because it is attracting the anions. Alright. And then this comes to the story of, I'm back here, of oil rig. Let me bring it back. The story of oil rig. Remember what is oil? It says oxidation. Oxidation is loss of electrons. What about reduction? Reduction is what? Reduction is gain of electrons. Are you with me? So now when we talk about oil rig, how does it fit in here? We are saying the positive here, the positive, which is the cations, repeat again, these cations will be attracted to the cathode, and when they are attracted to the cathode, they are going to gain electrons. You see, they are going to the negative, they are going to gain electrons. Hence here we are saying at the cathode, reduction take place. You see, meaning there is what? There is the gain of electrons here. And then what about at the anode? At the anode we are saying oxidation take place. Now, oxidation, remember, is the loss of electrons. With that, then you can conclude the direction of the flow of electrons, and we are saying since it's the loss, the electrons are going to be lost from the positive to the negative. So we call this the direction or the flow of electrons. So okay, so where are they flowing? They are flowing from the positive terminal to the negative terminal, and then this cell now acts like an electron pump. You see, it's an electron pump because it is the one, as we said, that is causing everything to happen. That's why we call it an electrolytic cell. Repeating again, why is it called an electrolytic cell? Because it is converting what? Electrical energy, then it is converting it into what? Into chemical energy, or causing chemical reactions. Okay, so this is in basically what we talk about an electrolytic cell. One might even go further to say, all right, since you are saying the negative ions, we call them the X minus ions. So we are saying when they are attracted to the cations, they lose electrons. So this is how we write it when they lose electrons. So from the negative ions, they becomes X and then plus the electron. This is the reaction that is happening at the anode. And then what do you call it? We call this reaction the oxidation reaction. Why? Because there is loss of electron. You see, this electron is lost. And then what about what is happening at the cathode? Now the Y plus at the cathode, here the Y plus will gain the electron that was lost from the side to give us a Y. And then now we call this the cathode. Alright. And then at the cathode, what is happening? A reduction takes place. And what is reduction? Reduction is gain of electrons. So guys, this is in basic the electrolytic cell, which you are expected to know. So now in the next lesson, what I'm going to do is I'm going to explain a few things in the next lesson. Number one, I want you to take note. Number one, we're going to look at the decomposition of copper chloride. Decomposition of copper chloride. It's a very good example of the electrolytic cell. Number two, we're going to look at the electrolysis of sodium chloride, which some they call brine, right? And then what do you do in electrolysis of sodium chloride? It is where you get your hydrogen, your chlorine, plus your sodium hydroxide, right? So this is the chloroalkali industry. Very important for you to know what is happening there. And then also we will look at the purification of copper using the same purification of copper. All right, and then we also look at electroplating, because this process is used in electroplating. So this is what I just want to bring to you in the next lesson. It might not be one lesson, but I just definitely going to talk about the decomposition of copper chloride, and then we're going to use the electrode or the reduction potentials so that you can see how to apply them. So we are definitely going to look at this too. If ever it forces us, we will then have another lesson that focuses on the other two. I want you to join me again in the next lesson. Thank you.